Okay, I think you're really going to like this next example. What I'm doing in this example is starting with this example that is on the ZIO Streams website. So you can see that what it does is it generates an element and then it uses repeat ZIO. And repeat ZIO just means keep doing this indefinitely. Keep generating elements forever. And then immediately after that, there's this buffer call that says buffer 16 elements here. Then it goes to map ZIO and it calls process. Then there's another buffer here. Map ZIO is just like having a map call right here, except that this function is going to be an effectful function. So you see when you look at process up here, it returns a task. And as you know from previous courses, that's a ZIO type right there. And that's what we mean by an effectful function. So again, it calls process that time, says buffer this here, then call that again, and then have another buffer, and then print the elements here at the end. So I use this as inspiration for the program that we're about to look at. And if we scroll down here, you could see what I've done as far as making changes here. So as in their example, I have repeat ZIO, and there's a definition down here that says repeat ZIO creates a stream from an effect that produces a value of type A and then repeats forever. So that's exactly what's going on there. Then we have the buffer of 16, and then I started changing the code. So I have step 1 right here inside of map ZIO. Step 1 is going to have a delay. Then I'd have a tap call here. So I say after step 1, print this output. Then we have the same buffers before, then another map call. This one is now step 2. Then we do the tap again, and we say after step 2, print that out. There's another buffer call here, and then a tap where we print the elements as they come to this point. And then I added a take here so we can limit the number of elements we're going to take, and then run drain here at the very end. So all of this code relies on some parameters up here, some delay parameters that I have set up. So I have a generation delay of 5 milliseconds, so that's in this generate element function. So inside of here, you can see that I'm using a ref, and I've talked about this type before. So we're using this ref to generate elements. We're using update and get. You can see I'm just incrementing them by 1. And a key here is that I'm sleeping for the generation delay right there. So that's 5 milliseconds initially. And this is the really fun part of this program, is that you could change these delays and see a lot of other interesting behavior. So then we have step 1 right here, and all it's actually doing is multiplying the value that it gets by 2. So it takes an int value here, it's returning a task event there, and all it's doing is that right there, doubling that value. But the key is this delay right here, and that's the first delay, and I made that 6 seconds right there. Step 2 is basically the same as step 1, except instead of multiplying by 2, I divide by 2. So in the end of the output, when you see the output over here, the numbers that we're generating up here, like we'll generate number 1, that'll be doubled to 2 here, and it will be reduced to 1 back here. So I wanted to make sure that when we get the output over here, we can trace that output over here to the generated element. So that's why I'm using these algorithms right there. And this one has a second delay. So right now that one is set for a whopping 15 seconds. And then I don't care too much about this last delay, the 15 milliseconds, but that's something you can play with. Actually, what you'll see is you're going to want to play with all of these so you can get to be familiar with how the buffering code works. And then the last thing I have here is the number of elements to take. So I'm saying right here at the end, I just want to take 20 elements right here at the end. With that take call, just take 20. And we'll see how that works with all these buffers going on inside here. And then the only other thing we have here is the print element function. And again, it just does a print line with this output here and then has that output delay. And again, this is one I'm not going to look at too much, but you may want to play with that output delay once you see how these buffers start to work over here. So let's see, what else can I tell you? So when we generate elements, I'm using the green icon. In step 1, I use a small orange diamond. In step 2, I use a larger orange diamond. When we print the output there, I have the check mark. And after step 1, I have a small blue diamond, and after step 2, I have a large blue diamond. So I think that's about all to say for right now. Let's move that over there. And let's start running this so you can see how that works. So I wish I could do, what I want to do is move this. What you really want to do is be able to see that code and this code here at the same time. Okay, great. So now we can see that. Actually, let me just stop that right there, or right there. Let's go ahead and kill that. And what I did there was expand that. So what I want to show here is you're seeing that we're generating all these elements 1 through 18 and then even 19 down here. So what's happening is that we're generating elements using the counter ref right here. And because there's a buffer right here of size 16, it's generating these elements as fast as it can because there's only a 5 millisecond delay here. And again, there's a 6-second delay for step 1 right here, right now. So it's generating these elements over here. Basically, every 5 milliseconds, it's creating a new one. Right here, it did enter step 1. And then you see that it creates all these other elements. And then we sat there for a little while before it said, oh, okay, I'm done. And now after step 1, the output is 2. So we went into step 1 with the input of 1 here, and then we're coming out with the output of 2. And then after that, we enter step 1 with a value of 2, and then we're generating element 19. And then finally, you see here, it's finally entering step 2 down here with 1 element. And that's that 2 value right there. Came out of step 1, and now it's going into step 2. So the first thing I wanted to show was the effect of that buffering right there. And in fact, if we change this to something like 32, let's come over here and run that again. And I'll kill that right away. And you can see what is going on here is it's generating elements 1 through 34. And it's entering step 1 right there. So 1 element is coming out of the buffer and going into step 1 right there. And that's part of the reason we're getting up to 34 right here. So you can see in this initial configuration, I'm generating these elements very quickly. And then the first delay is 6 seconds. So mostly all we're doing is generating elements very quickly and nothing else is happening. So let me change that back to 16 right there. And now let's change this to something smaller. How about something like, I don't know, 200. And let's see what a difference that makes over here. Okay, you can see that's making quite a difference over there. I'm going to go ahead and stop that one there. So now you can see we're generating elements 1 through 18 again, just like we did before. We entered step 1 here. Now we're coming out of step 1 very quickly. So after step 1, we have 2. Then we have another value 2 going into step 1. So then as this value enters step 1 right here, so then what's happening here is after a new value entered step 1 in here, that's getting that element out of the buffer. So then the buffer is saying, oh, okay, I'm ready to take another element. So it calls back here and says, I can take one more element. So that's where we get generating element 19 right there. And now, because step 1 is much faster than it was before, you can see that we're entering step 2 with that initial value. Then the 4 comes out of step 1, 3 goes into step 1. Then we have that feedback from the buffer. You just took an element out of my buffer, so I can call back here, generate another element 20. And in fact, if we make this as fast as the generation delay, now what you can see here is that we're really waiting for step 2. Okay, and I killed that. So as I scroll back here, you should see generating more elements, entered step 1. Here is where we enter step 2, right there with the value 2. And then that's going to keep generating elements and going through step 1. But if you look through here, you're not going to see step 2 until the very end. And then finally we see after step 2 right here. So you can see it's finally finished with the first element right there. And that's because we're multiplying the value by 2 here and dividing by 2 here. That's how I can tell that this 1 is the first element. And as soon as it's done with that one, it says, oh, okay, give me another one. So it takes in the number 4. And then 15 seconds later, it's going to finally be finished with this one right here. And another thing you can see from this particular example is now we have generated 35 elements. So what's going on there is we have a buffer size of 16 here. We have a buffer of 16 here. So this one is getting filled up. Then all those values are going through step 1. This one is getting filled up, and as this one fills up, we get more elements generated here. So you might see a slight pause. The timing is so fast, I don't know that we'll see it. But basically, we're generating elements as fast as we can. They're going into step 1 at the same speed. And now, even though you can't really see it, all of these first 16 values are coming through here, here, there, And now they're ending up in this buffer right here, the first 16 values. So then there's some feedback that says, hey, I'm full right here. And this buffer is saying, I'm empty over here, so please generate some more elements. I can take 16. And that's where you see this generating elements output right here. So that's filling up this buffer again right here.